All right, let's talk about the sun. We see it every day, right? It's that big, familiar star at the center of everything. But what if I told you there's a whole other side to it? A hidden side that's violent and chaotic and honestly kind of strange. It's putting on this incredible show 24/7, and we can't even see it. So let's dive in and uncover the sun you really don't know. Okay, so let's start with what seems like a really simple question. What color is the sun? I mean, you'd probably say yellow, right? Or maybe orange when it's setting. On a super bright day, it can even look white. Seems pretty straightforward. But is it really? Okay, well, if that's true, then why do scientists see this? Yeah, a glowing, kind of spooky green ball. What on earth is going on here? Turns out, figuring out why the sun looks green in this picture, well, that's the key to unlocking some of its biggest, most powerful secrets. So to solve this whole green sun mystery, we've got to start with a basic limitation. And it's not a limitation of the sun. It's a limitation of us, of our own eyes. See, it all comes down to a simple biological fact. Our eyes, they can only see this tiny, tiny slice of what's actually out there. We're tuned in to what scientists call visible light, the classic rainbow of colors. But that's like being able to hear only one radio station when there's an entire universe of broadcasts happening all around us. And here it is. This is the full electromagnetic spectrum. You've got everything from radio waves on one end to X-rays and gamma rays on the other. And do you see that tiny little sliver right there in the middle? That's it. That's visible light. That's everything we've ever seen with our own eyes. The sun is just blasting out energy to cross this whole thing, and we're basically blind to almost all of it. So, if most of this light is totally invisible to us, how in the world do we get these incredible images? Well, scientists have a really clever trick up their sleeve. It's a way to translate all that invisible stuff into colors our brains can actually process. This technique is called false color, and it's a pretty cool idea. Think about it. Invisible light, like ultraviolet, doesn't have a color that we can see. So scientists just assign one. They can tell a computer, hey, whenever you detect this specific wavelength of ultraviolet light, show it to me as green, or blue, or red, whatever works. It's all about making invisible data totally visible. And this tool is used for all sorts of things. It's incredibly versatile. So that green sun on the left, it's not really green, of course. That green is just representing extreme ultraviolet light. And over on the right, those colors on Mars aren't the color of the ground. Nope. They're showing us where methane gas is concentrated in the atmosphere. It's like translating a book from a language you don't know into one you do. Okay, so we've solved the mystery of the green sun. We get it now. We know how scientists are able to see these wild images. But that leads to the really exciting question, what are these images actually showing us? Well, this new way of seeing reveals the sun for what it truly is. A chaotic, magnetic powerhouse. And here it is. This is the big aha moment. On the left, you've got the sun in normal, visible light with those familiar dark sunspots. And on the right, that's a map of the sun's magnetic fields taken at the exact same time. Look at that. It's a perfect match. Those sunspots aren't just random dark smudges. They are literally the footprints of these incredibly powerful magnetic forces bursting through the sun's surface. And these magnetic fields, they are anything but calm. They are constantly moving, constantly in this violent dance. They stretch out like rubber bands, they get twisted up into knots, and sometimes they snap and reconnect with this absolutely explosive force. All this magnetic chaos, that's the engine driving all the crazy dramatic stuff the sun does. For example, when those magnetic field lines snap back into place, bam, they can release a staggering amount of energy all at once. And that's what we see as a solar flare, this sudden, brilliant flash of light and radiation, just like the one you're seeing right here. But that's not all. These magnetic fields also act like these giant cosmic puppet strings. They grab hold of the sun's superheated atmosphere, what we call plasma, and they pull it and shape it into these absolutely magnificent loops. You are literally seeing the invisible structure of the magnetic field because it's being traced out by millions of tons of glowing hot stuff. And when I say superheated, I am not kidding. The plasma that's trapped in these magnetic loops, it reaches temperatures of over 1,000,000 degrees Celsius. I mean, that is just mind-bogglingly hot. especially when you realize the sun's surface, the part we can see, is only about 5,500 degrees. So its atmosphere is hundreds of times hotter than the actual surface. How crazy is that? And the scale here, it's just almost impossible to wrap your head around. Take just one of these loops of plasma. It looks so graceful from this far away, right? But it's so huge that you could line up 10 planet Earths side by side just to get across it. 10 Earths. And every now and then, the magnetic field that's holding one of these massive structures together just gives way. It becomes unstable and erupts, blasting billions of tons of solar material out into space at mind-blowing speeds. This is a coronal mass ejection, or a CME. It is the biggest, most powerful kind of explosion in our solar system. Now, these cosmic fireworks are absolutely spectacular to look at, but they're not just some distant light show. These eruptions are the source of what scientists call space weather. And when one of these things is aimed right at us, it can have a major impact right here on Earth. Even on a totally calm day, our planet is constantly swimming through a stream of charged particles flowing from the sun. We call it the solar wind. But thankfully, Earth has its own built-in defense system. We have this powerful magnetic field that acts like a giant invisible shield, deflecting most of that radiation away. But a really big event, like getting a direct hit from one of those CMEs, it can be so powerful that it punches right through our planetary shield. The geomagnetic storm that follows can cause all kinds of trouble. We're talking damage to satellites, major disruptions to our power grids, interference with GPS and all our communications, basically everything we rely on. It's even a radiation risk for astronauts. Now, on the plus side, it's the same interaction that creates those absolutely beautiful auroras at the North and South Poles. So yeah, the sun might be 93 million miles away, but its wild, chaotic magnetic life has very real consequences for us, right here in our modern, tech-heavy world. We are totally, fundamentally connected to that star, for better and for worse. And you know what? That connection goes even deeper, way deeper. Beyond all its violent power, the sun's family, stars, they're literally our creators. You've probably heard the astronomer Carl Sagan's famous line, "We are made of star stuff." And it's true. The carbon in our bodies, the iron in our blood, every single one of those heavy elements was forged inside the fiery heart of a star billions of years ago. So the next time you look up at the sun, remember, you're not just looking at some distant ball of fire. In a very real way, you're looking at family.